Lesson 43, the chi-square test for independence. Example 1. Based on the results of the Sierra College Elementary Statistics Student Survey, can one conclude that a student's rating of their mathematics ability is made independent of their gender? Now, the answer to this question could either be yes, they are independent, or no, they're not independent. Thus, a hypothesis testing procedure can be used to address this question statistically. Now, since the issue under investigation in this example is whether the events are independent or not, the chi-square test for independence is used to determine whether two events are independent of one another. Now, the results of this hypothesis test procedure are going to be based on the results of the Sierra College Elementary Statistics Student Survey. Thus, the observed frequencies are obtained by looking at the results of the Sierra College Elementary Statistics Student Survey. These results can be organized in the form of a contingency table, where the first question, what is your gender, which had two categories, male and female, are displayed across the rows of the contingency table. And question 3, how would you rate your ability as a mathematics student, which had three categories of responses, below average, just average, and above average, are displayed along the columns of the contingency table. Thus, the observed frequency of 2 here is the result of having two males who rated their math ability as below average in the Sierra College Elementary Statistics Student Survey. And the observed frequency of 4 here is the result of having 4 students who were both female and rated their math ability as above average. Now we could refer to the following chart to help guide us through the steps of the chi-square test for independence. Starting with stating the hypotheses. In the chi-square test for independence, the hypotheses HO and H1 are always expressed in the same manner. HO is always that the events are independent, and H1 is always that the events are not independent. Now that we've stated the hypotheses, we then state the alpha, the level of significance for the test. Here we'll use the customary alpha of 0.05. Next, we can turn to the TI-84 calculator's chi-square test command in order to help us calculate the p-value we need to reach our decision. But in order to do this, we first need to enter the observed frequencies into an R by C matrix. So here we have the results displayed as a contingency table. So on the TI-84 calculator, we can enter this data into a matrix by pressing second, matrix, arrowing over to edit. Pressing enter will select matrix A. This contingency table has 2 rows representing the 2 categories, male and female, and 3 columns representing the 3 categories, below average, just average, and above average. Now we can enter in the data starting with the first row. The observed frequency was 2, 11, and 4 across the first row, and the observed frequencies were 6, 17, and 4 across the second row. Now we can go to the chi-square test command by pressing stat, arrow over to tests, and then arrow up until the cursor is next to chi-square test. Press enter to select. We entered the observed values into matrix A. The calculator will place the expected results in matrix B, and then we press enter under calculate. Here we see the p-value. Rounding it off to 3 places after the decimal, we get a p-value of 0.586. So now we can reach our decision. Since the p-value of 0.586 is not 0.05 or less, the decision is to not reject HO. And when we do not reject HO, we have sample evidence indicating that HO is valid. Thus, here we can say that the events are independent. So based on the results of this chi-square test for independence, we could reach the following conclusion. Therefore, based on the results of the Sierra College Elementary Statistics Student Survey, one can conclude that the student's rating of their mathematics ability is made independent of their gender. So, it appears that gender does not affect the way in which a Sierra College Elementary Statistics student would rate their ability as a mathematics student. That is, the student's response to the question, how would you rate your ability as a mathematics student, were essentially the same for both males and females. We can see this by looking at the results in the contingency table. Here, the distribution of mathematics ability ratings made by the males followed frequencies of 2, 11, and 4, which was low, high, low, or followed somewhat of a bell-shaped distribution. The same pattern was observed for females. The distribution of below average, just average, and above average math ability ratings for females had frequencies of 6, 17, and 4, giving this low, high, low, or bell-shaped pattern. So regardless of whether the student was male or female, the overall pattern of students' rating of their math ability followed this bell-shaped distribution from low, high to low across the categories of below average, just average, and above average.